Hello everyone. Let us now proceed and look into the next module that is called as functions. At the end of this particular module, you will be able to write your own user-defined functions and apply the concept of recursion to solve the problems. Let us look at the coverage of this particular module. We'll start off with the introduction and we try to understand the definition of functions and its advantages, types and components of functions, points related to function parameters, variations in functions, passing arrays to function, recursion, its advantages and disadvantages, example of Fibonacci series, and before we conclude, we look into recursion versus iteration. Now let us proceed with the introductory part of functions. Knowingly or unknowingly, we rely on so many persons for so many things. We know that man is an intelligent species, but still, born as a human being, we cannot perform all the life tasks all alone. As human being, we have to rely on others. For example, you may call a mechanic to fix up your bike, or probably you hire a gardener to mow your lawn, and so many other tasks in life which we have to rely on people. You know, of late, majority of us we rely on maid for cleaning household items and utensils and all not. A computer program finds itself in a similar situation. It cannot handle all the tasks by itself. Instead, it requests other program-like entities called as functions in C to get its task done. The soul that inhabits the vast body that C is a minuscule entity, and that's the surprising thing. C is made up of an unbelievable paltry vocabulary, about 32 words if I'm right. But through this limited vocabulary, it is able to carry out the most formidable task with consummate ease. The flexibility we sampled so far was still rigid. We moved within the structured innards of C, looking at control structures like for, while, int, and character were actually pieces of those structures that we have discussed earlier. However, we did deal with an element completely aligned to C, that is printf statement. Let me spill out the secret now. C does not understand printf at all. Functions compartmentalize duties, reducing chaos and confusion. Extent of their reach and their fascinating utility will unfold as we go along. Suffice it to say that C and functions, you can build a bridge to the sky. Now, before we proceed with the technical aspect of functions, let me give you a simple example. Assuming that you stay in Bangalore city and you reside in Jayanagar. You want to meet your girlfriend in Brigade Road at 6 p.m. Keeping all the constraints in mind, like traffic, there is tremendous traffic in city like Bangalore, the time required to drive, and so many other parameters probably, you decide to leave your place by, on a two-wheeler, preferably a motorbike, at 5 p.m. because you want to meet your girlfriend at 6. Now, try to understand this, what I'm saying. Leaving your place is nothing but the execution of the main program. And while passing, let us say near Lal Bagh, your vehicle gets punctured. So what you basically do, you park the vehicle by the side of the road and go ahead in getting the mechanic to repair it. Now what is actually this is happening now? Stopping of the vehicle is nothing but the temporary stoppage of the main program, and getting the mechanic is actually called as a function. Now mechanic comes and he does the job. This is nothing but the execution of the statement which comes in the body of the function. Once the job of the mechanic is over, he pushes off and you will leave towards your destination. That means what? The job of the function is over and now the main program starts resuming its job. Now that's the definition of a function. What it says, It is a self-contained block of code that performs a coherent task of some kind. I repeat, a self-contained block of code that performs a coherent task of some kind. Now let us look at the advantages of function. Of course, as we proceed further, you will see in detail how these advantages are carried out in functions. First and the foremost thing, the length of the source program is reduced. It avoids rewriting of the code. You will see how it avoids rewriting of the code. It makes program easier to understand, and needless to say, the debugging becomes easier. Let us have a look at this. You have two functions. One is called as calling function and the other one is as called function. Now what happens is, in the example that we have discussed, a boy who is going to meet his girlfriend, correct? He is called as a calling function. And the mechanic, we call him as a called function. That is because you are going to call a mechanic. So same thing in C programming language. Somebody should be responsible to call a function. Now calling function calls, its activity gets suspended, the called function gets activated, and he wakes up. Right? Now when calling function activity gets suspended, it goes to sleep. And once the calling function goes to sleep, right, that means what? When you call a mechanic to fix up your bike, you are actually doing nothing. When mechanic is in the process of fixing up a bike, you are actually standing next to him and just watching the proceedings that is happening. So that's what I say, your activity gets suspended and you go to sleep. Now what happens? When you are not doing anything, actually mechanic is doing some task. And in this case, your mechanic is actually repairing a bike. And then once the bike is repaired, he will give you the complete repaired bike and he pushes off. He returns back to his garage. Then what happens? You come to life again. Now what do I mean by you come to life again? Actually speaking, once the mechanic returns the bike, you actually start the bike and you proceed towards your destination of meeting your girlfriend. Now that is what you mean to say comes to life again. Now let us look at the types of the function once we know the definition of a function. Now in the world of C programming, there are two types of functions. One is called as library function and the other one is called as user-defined function. And before we proceed, these are the components of the function. You have declaration, which is also called as a prototype. You have something called as function call, and you have something called as function definition. Let us see all this one by one. Now look at the declaration part. Normally, to be declared prior to its use, which basically allows the compiler to check its type of arguments that we are using. The syntax is return data type followed by the function name and different types of parameters in the bracket. Now, what is the advantage of this declaration? If you do not declare the declaration part of the function, error checking will not be performed. So to be on safer side and a mark of a professional programmer, it is always good to have the declaration part. Next comes the function call. It is a place in the source code where you actually call the function. And the third one is function definition. Now what exactly you mean by function definition? It is a collection of the program statements. Now, why prototype or declaration is important? The first and the foremost thing is it tells the return type of the data that the function will return. Second, it tells the number of arguments passed to the function. Third, it tells the data type of each of the passed arguments. Also, it tells the order in which the arguments are passed to the function. Therefore, essentially, the function prototype specifies the input-output interlace to the function. That is, what to give to the function and what to expect from the function. Now, what is another name for prototype of a function? Prototype of a function is also called as signature of the function. Now let us have a look at certain points related to functions. First and the foremost thing is function prototype tells return type, type of the arguments, and name of the function. Function prototype ends with semicolon. The first line of the function definition does not end with semicolon. The arguments passed while making a function call are known as actual arguments, and arguments received by the function call are called as formal arguments. We will see all these points one by one when we look at the user-defined functions. Now let us have a look at simple example. Now I have this program where I have written a main. Now main is actually a library function. A library functions in C language are inbuilt functions which are grouped together and placed in a common place called library, right? And all C standard library functions are declared in many header files which are saved as .h files. Now, when we include these header files, right, the command all C code of the header files are included, then this C program is compiled by the compiler and executed. Now, why we basically use library functions is the four reasons. One of the important reasons we use library function is simply because they work, and these functions have gone through multiple rigorous testing and are easy to use. They are standard library functions. A dedicated group of developers constantly make them better. In the process, they are able to create the most efficient code optimized for maximum performance. It also saves considerable development time. As a matter of fact, we should not worry about creating them once again. It saves valuable time, and your code may not always be the most efficient. And the last one, according to me, is the functions are portable, meaning with ever-changing real-world needs, your application is expected to work every time, everywhere. And these library functions helps you in that they do the same thing on every computer. This actually saves time, effort, and makes your program portable. Now let us look at this. I have a main here, and I have three user-defined functions called as 1, 2, and 3. Now the user-defined functions are written, and then it is followed by opening and closing brackets. Okay. Now 1, 2, and 3 in this case are called as user-defined function. Means they are those functions which are actually written by the programmer to carry out their own specific needs. If I write a program where the user-defined function is ONE, it is not necessary that the another programmer should also have a user-defined function called as ONE. Since my requirement is I need a user-defined function called as 1, I am using user-defined function 1. Similarly, I am also using user-defined function called as 2 and 3. Now, look at this. Every C program starts its execution from main and ends at main, irrespective of what you do in between. So in this case, I am calling a function called as 1 from main. So the control comes to function 1, and then it goes back to main. Similarly, I call another function 2, where the control passes from main and goes to user-defined function 2, does the job of the function 2 and takes the control back to main. And similarly, it goes to 3. Now in this particular example, the three user-defined function 1, 2, and 3 have been called by main, and then the control has gone back to main. Now let us try to understand this example right, with a forum how it actually happens in C program. So this is what I have my main program, and then I'll have one couple of statements, right? And then I call a function called as a simple function without any so-called parameter. So ONE is the name of my user-defined function. And then I have some more statements, and I have another user-defined function called as to. And then I have some more statements related to main, and then I'll have one more user-defined function called as 3. And then I have some more statements to execute, and then I close my main program. Now basically what happens is, this is my line number 1. So I just say line number 1, it gets executed first, and this will actually call a user-defined function called as ONE. So let us say I have written the function ONE here with opening and closing braces. So this is my user-defined function called as ONE, and then I will have a couple of statements in ONE, and then I have one more user-defined function called as 2, and another user-defined function called as 3. So this is my user-defined function 2, and this is my user-defined function 3. Now let us see how exactly this works in C programming language. Now this is a huge program. Assume that this is a huge program, and you have made use of 3 user-defined functions called as 1, 2, and 3. So when you compile and execute this, your program starts executing from main. It will execute line number 1, and then this ONE is nothing but you are calling a user defined function, right? So main is actually calling ONE. So main becomes a calling function, and your ONE becomes a called function, correct? Now understand, main becomes a calling function, your ONE becomes a called function. So the control will branch to ONE, and it will execute these 2 lines which is there in the body of the user defined function 1. And this curly brace will ensure that the control takes back to this particular place from where it has been called, right? That is exactly what your mechanic does. Once your mechanic actually repairs your bike, he will not take the bike and push off. He will actually give the repaired bike to you. And same thing happens in C. Once all the statements which comes in the body of the user defined function is executed, the control should go back to the same place from where it was called. So it will come back here, and then it will execute this set of statements, and then you are again calling a function called as 2. At this time it will branch its control here. It will execute these 2 lines which comes in the body of the function TWO. This curly brace will take the control back here. Then it will execute this set of lines. Then you are calling another user defined function called as 3. Control comes here. It will execute this set of lines. This curly brace takes the control back to this place, and then sequentially you proceed down and you execute this set of statements, and finally your operating system will encounter this closing brace, which is the closing brace of main program. So as a matter of fact, this is how the program works, where it makes use of certain user defined functions, right? And then the control, how it passes to those user defined function, and once the control passes there, actually what happens and how the control comes back to the place from where it was passed, and finally it goes and stops at curly brace of your main program. So here you see that the main is actually responsible to call function 1, main is actually responsible to call function 2, and main is actually responsible to call function 3. And you see that at the end of every user defined function, the control goes back to main, and at the end of the day, correct, your program which starts executed from main finally ends at main. Now, apart from this, you can also have another scenario, right, which is slightly different from the first scenario, correct? Now, say for example, what happens is you call a mechanic to fix up your vehicle. What you do is you go to the garage and you tell the mechanic, you know, my vehicle is punctured, why don't you come and fix it up? And with great enthusiasm, the mechanic comes. And then once he comes and he sees your vehicle, he says, I'm sorry, gentlemen, I cannot fix up your vehicle. Now you are a little bit worried because you are in a good mood of going and meeting your girlfriend actually. So what happens is with great disappointment, you'll ask mechanic as to why, what happened. The mechanic says, I'm sorry, gentlemen, I'm actually a four-wheeler expert and I cannot repair, the two-wheeler. Correct? In real life, I do not know how far it works out, but let us assume that we have two types of mechanic, one who is expert in four-wheeler and the other one who is expert in two-wheeler. Correct? Then he says, I cannot do it actually. Why don't you try out for some other mechanic? Now, you possess a sort of a lethargic attitude, and then you say that, from where now I should go and search for a mechanic who can repair my two-wheeler. Why don't you help me in getting a mechanic? Right? Now, see, that's the point here. In the earlier case, you called a mechanic. Now, in this case, you call a mechanic who cannot do your job. In turn, he will call another mechanic. Now that's the difference between the previous slide and this slide. See here, main is calling function 1. That means you is calling a mechanic. Now that mechanic cannot do a job, so he calls another mechanic. So the another mechanic is actually called by the first mechanic. Understand? In the previous case, mechanic was called by you. Here, the first mechanic is called by you. On the other hand, the second mechanic is actually called by the first mechanic, and that is the prime reason I have an arrow going from 1 to 2, from user defined function 1 to user defined function 2. Similarly, I can also have a third mechanic called from 2, right? So user defined function 2 is responsible to call user defined function 3. Now once everything is done, in the sense all statements which comes in the body of function user defined function 3 is executed, control will go back to 2. From there the control will go back to 1, and from there the control will go back to main. So even in this case, we see that the C program starts executing from main and ends at main. Now let us see how this can be converted in the form of a C program. Right? So this was our first example. Now what is going to happen is I am going to remove this 2 and 3 user defined function here because they are not going to be called by main program. So I have one here, and we have seen in the PPT that one is responsible to call user defined function 2. So I call user defined function 2 here. So control will come here, and then I will call user defined function 3. Okay, now this is the change. So the execution still remains the same with a slight change. Line number 1 will be executed, then you call a user defined function 1, the control comes here, and then this particular line will be executed, then you call a user defined function 2, the control comes to here. Please understand, it comes to here, and then this will be executed, then line number 3 will be executed. So if I have to tell you very specifically, let me put the numbers here. So this is line number 2. For simplicity, let me call this as line number 3 and 4. Let me call this 5 and 6. And let me call this as 7 and 8. So let me tell you the sequence of the execution. Okay, now line number 1 will be executed first. Then you are calling a function 1. Line number 3 will be executed next. Watch out. This is how it is going to execute. Line number 1, then you call a user-defined function. Line number 3 will be executed. Then you are calling user-defined function 2. So the control will branch to this particular place. It will execute line number 5, right? So let me see. Let me write the flow 1, 3. That is how the statement will be executed. And then the control will come after executing line number 5. It will go to user defined function called as 3, and it will execute these two statements, right? Line number 7 and 8. So I have line number 7 followed by line number 8, and this curly brace will ensure the control goes to this particular place because user defined function 3 is actually called by user defined function 2. Recollect, in the earlier case, user-defined function 3 was actually called by main. But in this case, user-defined function 3 is called by 2. So the control comes here and then line number 6 will be executed. So I go back here, I write line number 6. That will be executed. This curly brace will ensure the control goes back to here because this was the place where user-defined function 2 was called, correct? And then it will execute line number 4. So I have line number 4 here, which gets executed after line number 6. And once line number 4 is executed, this is the closing brace of user defined function 1. So the control will go back to this place and line number 2 will be executed. So this is what I write here. Line number 2 will be executed, and then this is the closing brace of main program, which tells that the end of the program, right? So here also, irrespective of the order in which you call your user defined functions, right, the C program always starts executing from main and ends at main.